What's going on, guys? Got a nice little short case study today. This one was pretty simple, was a really nice one I liked. Going to be quick. There's not a lot to this one just for the testing that it was, but we had a 2017 Honda CRV with a local cam fault. The fault was between the front radar sensor and the multi-purpose camera. There wasn't a ton of history on this car other than there was another issue. Originally, there was a charging issue on this car. The shop found a C's alternator, so they replaced that, did alternator. I'm sure they did a belt as well on this one. And they also said they did a battery. They did all of that, and then they had a bunch of warning lights on. Very common on Hondas after you do a battery disconnect to have a bunch of warning lights on the dashboard. Usually you'll need to do like an all sensor or take it on a nice test drive and it'll clear all those lights and relearn everything it needs to relearn. In this case, the customer did do that and they still had some warnings on the dash, which I will pull up here. I took a little video. So these were the warnings still on the dash. It would pretty much just flash between, let's pull this up. It would pretty much just flash this warning right here, adaptive cruise control problem, and they couldn't resolve this issue. Now, a little pre-scan on the vehicle showed we had this code right here, U12B7, millimeter wave radar local CAN malfunction. Now, if you're not familiar with these systems, these modules will be on a regular CAN network, and then there will also be a local CAN network as well. So I have a quick little wiring diagram right here. The local CAN would basically be these two wires right here, which communicate just module to module. So these modules want to be able to talk to each other outside of the regular network, which would be FCAN right here. So 6 and 7, we got this green and yellow. This would be the regular FCAN network that we have all the modules on. As you can see here, we have it on the electric brake boost, the VSA modular control unit, the multi-purpose camera has it as well. All of these modules will be on a regular CAN network. Now we also have this pin 3 and 4, which should be at the radar, and then pin 6 and 12 at multi-purpose camera. That will be our local CAN between the two modules. So the issue based on the code that we have here, we're looking at a fault between this local CAN, not the FCAN. So I pulled up just a wiring diagram here to show me powers, grounds, and then the local CAN. I'm not so much concerned about the FCAN because I don't see a fault code indicating there. I do have communication to the modules. So first thing we did was we got that fault code right here. I did go in just to get a quick live data on like camera and radar to see if there was anything. These are pretty much the only two data PIDs they had that like told me something. And we had like 50 degrees on the camera, 53.6 on the radar. The car was sitting outside. They pulled it into the shop. It was a cold day. So these did kind of go up as I was sitting in the shop. So somewhat confirming to me that there's some type of communication to these two modules, and the only code that I have is just this local CAN. I don't have any other fault codes in here saying like loss of communication to the camera, loss of communication to the radar. If there is an issue with those, I would imagine, or I would suspect, I would have loss of communication codes to those modules setting in other modules. So you can just do a quick little search on this code and we'll do like a little description operation on it, see what that's going to have. So that's what I did on this. I pretty much did a pre-scan, got this little bit of live data, confirmed the code, took that video of the warning on the dash, and went right into my diagnostics. First thing I did was I wanted to get a wiring diagram just to see where I was going. This was the diagram I got, and I also got a couple screenshots of some pinouts of the connectors. We got the radar unit here, we got the multi-purpose camera unit here, and then these are just, I know where these are if you've worked on these systems before as well too. You're probably very familiar with Honda windshield cameras, always in the windshield, or the multi-purpose camera I should say. And then the radar on Hondas is usually, there's a couple different spots it could be, but this one was just like center of the grill. It's behind like a little piece of trim panel that comes off. So these red connectors here would be, this would be the radar, this would be the multi-purpose camera, and we have our pinouts. So this is where we're at. Now Honda has some fault code testing. I put this together because it's a lot of, you just click through these and it brings you to the next step. So I put all this together and there wasn't really the best testing for this code. We have the code right here, the U12B7, right? And pretty much wants you to verify that there's an issue right away. Clear the code, make sure it's duplicated and the code comes back, move on to step 2, right? Next thing it wants you to do is a quick little resistance test. Ohm out the wires between the multi-purpose camera and the millimeter wave radar. Wants it to be less than 1 ohm. Do that. Okay, yes, there's no opens. Move on to step number 3. That wants you pretty much to just check for any shorts to ground between both. Next we move on to step 3, which pretty much just wants you to check for any short to ground. Same thing. Is there an open circuit or at least 1 million ohms? Yes, the wires are not shorted to ground. Move on to the next step. Not looking for any, we're looking to like not have continuity with ground here. And this is your next test. You're looking for shorted CAN wires. Wants you to go between the two wires, 3 and 4, which would be 3 and 4 right here at the millimeter wave radar. Open circuit or at least 1 million ohms. Yes, they're not shorted. Go to step 5. So pretty much we're just making sure there's no wiring issues in that. Not really the best testing, but good enough. Not like they carry a crazy amount of load. It's just CAN wires. But ohm testing, I feel, is not really the best testing for stuff. It'll give you, I feel like a resistance test or ohming out wires is good if you find an open circuit. If you find open circuit, you know right away there's an open. I know what I'm going after now, and we got to fix this open in the wire. If it gives you a good reading, it doesn't really tell you how intact the wire is. It just tells you that there's potentially one strand there holding everything together. So we go to step 5, and it's multi-purpose camera unit check. Substitute a known good multi-purpose camera unit, step 1. Now, probably not something that most people have around. I'm sure the dealership obviously has these on hand, so this would be very easy testing, I would imagine, for the dealership, or if you're just a shop that has these cameras on hand. Most shops aren't going to have these on hand from my experience. So it basically wants you to substitute a known good camera, clear the DTCs, see if it comes back, right? If the code does not come back, you found the issue, replace the multi-purpose camera. If it does come back, it wants you to go to the radar unit module and check for any terminal tension issues, any poor connections, etc. If none are found, everything's okay. Replace the millimeter wave radar. Both of these will need a calibration when they get replaced as well. So not the best testing overall. In this case, I did not have a known good camera unit to put in there. So it would really just be a guess at which one it's going to be. You could do a new multi-purpose camera unit right out of the gate and see if that fixes it. If it doesn't, you could try a radar. These are expensive modules. I believe this radar is like $700, so not really something you want to guess at if you're unsure. So first thing that I did for testing this was I did just load tested the powers and grounds for these modules. So right here at the millimeter wave radar, we have pin number 1 would be power, pin number 8 would be our ground, and then multi-purpose camera 1 and 2 would be the power and ground. So ignition option, and then 2 is ground here. And then on this one, we have 1 and 8 for the radar, which would be 1 and 8 here. So if you had this full diagram, you'd see these went back to fuses. These are very easy modules to get to. So I just got right to the module to check, found no issues, lit my 1157 bulb, which depending which side of it you use, it's either 0.5 amp to 2 amps, I believe, current that it pulls. So a decent load tester. So I found no issues there. Always like to just test powers and grounds at modules right away. I've definitely been burned in the past. It's just good to know that it's good because you can get all types of weird issues if you have a bad ground or a bad power and there's any type of voltage drop on them. You can get all types of weird issues. So definitely good to get that out of the way, make sure that's good. So I did that quick. I did just do a quick continuity test between the two modules because they were easy to get to, just to make sure I had no opens. Now, I don't really need to do this if I'm going to scope it anyway. The scope waveform that I'm going to capture is pretty much just going to tell me that it's good to go. But in this case, I just did it anyway. I checked also for any shorts of power ground. Didn't find anything like that. I had good resistance between, which is this capture right here, 0.7 ohms. It was good on both wires. Now I am using my terminal kit to probe this as well. I did do pin retention. I found no issues. I had nice tight terminals. Also good to wiggle the wire. Just make sure you don't have any like issues where the wires connect to the terminals. So I ended up doing that and I found, this good continuity between the two modules. So on to my next thing. I did start initially with my U scope on this one just because it's very easy to pull out. The Pico scope is a little bit more of an involved setup. So I pulled out my U scope on this one and I had the multi-purpose camera unit plugged in and I'm testing at the radar, same right here. So I'm going across the CAN wires here. So I'm just checking at the radar. This is still plugged in, this is unplugged, and I'm just scoping one at a time because the U scope is a 1-channel scope on CAN high and low. And I did see like a glitch in it at first. And when I saw that, I was like, let me hook up my Pico scope. I'll do CAN high and low together and let me just get a better look at it, which is usually what I'll do. I'll do like a quick test out the gate with the U scope just to see what I'm dealing with. And if I see anything that looks a little off, then I'll hook up the Pico scope and go from there because we'll get a much better capture with that. So upon hooking up the Pico scope, we had a couple waveforms. So this one right here on the left was that glitch that I was seeing with the U scope. So I confirmed it with the Pico scope. We have a lot of time on the screen here to capture it, but this was that capture. I had the multi-purpose camera unit plugged in and we're scoping at the millimeter wave radar unplugged. And this is the waveform that I'm seeing. We have this like systematic dropout here where we're getting pulled down to ground. And to me, right away, that looked no good. I've never seen that before, but you know, I reversed this test and we had this capture right here, which was at the multi-purpose camera unit with the radar plugged in and the multi-purpose camera was unplugged. And this showed me a very solid waveform with no dropouts. So these two captures right here are just zoomed in on some of the waveforms that I captured. I had, you know, this would be a very small data packet in here. So much different time base as well too. We have 1 second per division. We have 10 milliseconds per division here. So this one's much more zoomed in. So this was a very nice, when I zoomed in, I have my voltages. We have our 1.5 to 2.5, 2.5 to 3.5, very nice looking waveform. These look good. I saw no issues at all with the communication on these. The only thing that I saw was this dropout right here, which I've never seen before. And this is what I'm going to go with as the fault for the local CAN. So had I not seen anything here, then you'd kind of have to just substitute a known good on this one. There'd really be like nothing else to test. Everything would have checked out. We've exhausted all options. But since I found something here, this is just more ammo to go against that multi-purpose camera unit. At this point, if I didn't already scope load test the powers and grounds, now would be my time to do that. But I like to just get that out of the way in the beginning. This way, now I know everything I'm testing. My wiring is all good to that module. Terminal tension is good. Powers and grounds are good. So I know that this is going to 100% lead me to determining a bad multi-purpose camera unit in this diagnostic. So I thought this was a really good one. I feel this does show the use of a scope where you would never really get to see this with a multimeter. You really just need to be able to graph this over a long period of time to be able to come to this conclusion. You know, if you look here, this is about like 3 seconds of time and then it drops out for a very short amount of time here and then it's right back. So it's a very small, you're talking like a quarter of a second that this is dropping out, if that, you know. So again, I think this is a really good case study on why oscilloscopes are great, especially in communication issues that you're looking at. So this pretty much is going to wrap this one up. Customer replaced the multi-purpose camera unit on this one, and it does require a calibration. So that's going to wrap this one up. I hope you guys enjoyed this type of content. Let me know if there's anything else you'd like to see in the future. If you like this style, I pretty much just jot down a bunch of notes from these diags that I do into one of these Notion documents right here. So if there's anything else you'd like to see or a different format, if this would be better on like Google Slides or something like that, let me know in the comments down below. I'm pretty much just jotting everything in here and then kind of just going over for a case study. So it just feels like the easiest way to kind of get this content out to you guys. Let me know if this is useful. Let me know if you like these at all. And that's pretty much going to wrap this one up. I'm definitely no expert. I learn every day. I try and spend a good amount of time in my free time studying as well to come up with, you know, better testing methods and stuff. These videos I'm just putting out there to just show my diagnostic process on things. Maybe you guys can get something from it. Maybe you guys could teach me something that I don't know. And I'm gonna keep rolling with these. We'll see what comes out of it, and I'll catch you guys on the next one.